How to evaluate logarithm. And these are the examples that we are going to do. The first example is evaluate log 16 base 4. We have log 16 base 4, log 16 base 4. You let log 16 base 4 be equal to any variable at all. So mine, I will let it to x. Then from here, you change it into index form. So changing this one to index form, the base here will go and carry the s to be the base there. So the 16 will become base, and the 4 will move towards here to become what? The base exponent what? X. Now, getting this one, we have to make sure that the base also are what? The same. But here, we know that 4 exponent 2 will give what? 16. We are changing. So 4 exponent 2 will give what? 16. Then, since the base are the same, 4 and 4, I can say that 2 is equal to what? X. Therefore, x is equal to 2. We have been told to evaluate this log 64 base root 2. Your first step, you let log 64 base root 2 be equal to what? X. Now, we change this one into what? Index form. That's indices. Index form. Changing this one into index form. The base here, when it crosses the equal sign, it will be still the base. So, we have what? 64 equal to root 2 exponent what? X. Now, from here, root 2, roots, when you change to index form, it is exponent what? Half. Exponent what? Half. So we will have 64 be equal to 2 exponent what? Half, which is the same as root 2, but here x is there already. Now, we have to make sure that we change, or let's simplify first. So we have 64 equal to x equal to 2, then half times x, we have what? Half x. Making sure that the base are the same. 2 exponent what number will give me 64? We have 2 exponent 6 will give me 64, then equal to 2 exponent half x. Now, the bases are the same, 2, 2. Therefore, I can equate 6 equal to half x. Half x. What do I do here? I have to make one x the subject by deciding to multiply or cross multiply. Cross multiplying, we have what? 6 times 2, and we have 1x. From here, 6 times 2 will give us what? 12 equal to what? X. Therefore, x is equal to what? 12. This is the third question that we are asked to evaluate. Your first step, as I said, you let log root 8 base half. This time around, I will let it to be y. So I'm going to find y. Your second step, you change this one into index form, where the base of the log in index form, it will still be what? The base. Then we will have root 8 equal to exponent what? Y. It is still what? The base. Now from here, as we said earlier, in indices, When you see root, it is exponent what? Half. So we have what? 8 exponent what? Half. And when you also come here, changing the position, we have 2 exponent negative 1. Finding the inverse of this one, exponent negative 1, then multiply by the half. From here, let's try to simplify it. We have 8 exponent half equal to 2. When you multiply this and that, we have what? Exponent negative y. Exponent negative 1 times y. Exponent negative y. Now, we have to make sure that the base are the same. Changing this one, if you have how many times 2 exponent what number will be what? 8. 2 exponent 3 will give me 8. Multiply by exponent half equal to 2 exponent negative y. From here, we can see that we have to multiply this and that. When you multiply 2 times 1 out of 2, 3 times 1 out of 2, we have 2 exponents 3 on 2, then equal to 2 exponent 1. Since the base are the same, I can equate the exponents. Since the base are the same, equate the exponent, then we have 3 on 2 y. But the question is, we want y, we don't want what? Negative y. I can decide to multiply by negative 1 or divide 2 by negative 1. So let's multiply 2 by negative 1. So negative 1 times 3, 2, then negative 1 times y. When you multiply this and that, what do we get? Negative 3 on 2. Then here we have what? Y, because negative 1, negative, positive. Therefore, I can say y is equal to negative 3 on 2. This is